Hello friends, so here is another question on the application of the concept of cross product. So here it has been asked to prove or to show that the two vectors a vector I cap minus 5 j cap and b vector 2 I cap minus 10 j cap, they are parallel to each other. We have to show it, we have to prove it. Okay. So how the concept of cross product can be used? So first let us find out the cross product and see what result are we getting. A vector cross b vector, simply the determinant I cap, j cap, k cap, x and y and z components of a vector, x, y and z components of b vector. So which is I cap into 0 minus 0, minus 5 into 0 is 0, minus 10 into 0 is 0, minus j vector 1 into 0 minus 2 into 0, which is again 0 minus 0, plus k vector, which is 1 into minus 10, which is minus 10, minus 2 into minus 5, which is minus 10, minus minus 10. So here it is 0 I cap minus 0 j cap or plus 0 j cap, okay, it doesn't matter, plus minus 10 plus 10, which is 0 k cap. So here the resultant vector a vector cross b vector is this much, 0 I cap plus 0 j cap plus 0 k cap. Magnitude is also 0. Now if you remember the definition, the basic definition of cross product, here cross product of two vectors a vector cross b vector, it is given as a vector b vector sine theta n cap, where n cap is the unit vector perpendicular to both a vector and b vector in the direction of the resultant vector. The magnitude of the cross product is simply a b sine theta. Okay, so here the magnitude of the cross product here is 0, a vector cross b vector, that is equal to 0. Here it is 0. That implies sine theta is equal to 0. That implies theta is equal to sine inverse of 0. So here it can be 0 degree or 180 degree. So there are two possibilities. Either the vectors a vector and b vector, they are parallel to each other, or the a vector and b vector, they are anti-parallel. Theta is equal to 0 degree, theta is equal to 180 degree. Here it is anti-parallel. So there are two possibilities. So as here the magnitude of the resultant vector, the cross product vector, is 0, so there are two possibilities. Okay, so we have proved that these two vectors are parallel to each other. It can be in this way, they are in the same direction, parallel in the same direction, or parallel in the opposite direction, or anti-parallel with respect to each other. Okay, so here is another question again to show or to prove that the given two vectors, a vector which is given as 2 I cap plus 3 j cap minus k cap, and b vector is 6 I cap plus 9 j cap minus 3 k cap, they are parallel to each other. So first we have to determine the vector product or cross product of the two vectors a vector cross b vector, simply the determinant I cap, j cap, k cap, 2, 3, minus 1 x, y and z components of a, and 6, 9, minus 3 x, y and z components of b. So it is I cap 3 into minus 3, which is minus 9, minus 9 into minus 1, which is minus 9, minus j cap into 2 into minus 3, which is minus 6, minus 6 into minus 1, which is minus 6, plus k cap, 2 into 9 which is 18 minus 6 into 3 which is 18. So here it is I cap minus 9 plus 9 which is 0 minus j cap minus 6 plus 6 which is 0 plus k cap multiplied with 18 minus 18 which is 0. So it is 0 I cap plus 0 j cap plus 0 k cap, that is A vector cross B vector. Magnitude of A vector cross B vector is also 0. Basic definition of vector product or cross product, it says that A vector cross B vector is represented as A vector B vector sine theta n cap. N cap is the unit vector in the direction of A vector and B vector. The magnitude is given as A vector cross B vector modulus, which is AB sine theta. Okay, AB sine theta. Here this magnitude is coming as 0. Okay, this magnitude, it is coming as 0. That means sine theta is equal to 0. That implies theta can be sine inverse of 0, which can be 0 degree or 180 degree. 0 degree for parallel, 180 degree for anti-parallel. Okay, so once you get this vector as 0 I cap, 0 j cap, 0 k cap, it means that the two vectors are either parallel or anti-parallel with respect to each other. Parallel when they are directed in the same direction, anti-parallel when they are directed in the opposite direction but parallel with respect to each other. Okay, so we have proved here that the two vectors are parallel or anti-parallel with respect to each other. First, because we got this result, and then as per this definition of cross product or vector product, when sine theta is 0, theta can be these two possibilities. Okay.